Yeah, today we're going to be looking into visualization, and basically we are going to quickly recap what we did in the last class, and then from there we quickly use some common visualization, and that is all going to be what we are going to do today. So let me quickly share our last class notebook. Let me share with us. Okay, go to your Google Colab as usual. Then I go to, of course, I already have the notebook. I just have to open the notebook, not new notebook. I want to, okay, the last one was visualization. Yeah, this. And this, the first thing we do is to import to bring our file into the collapse, and we just go to this folder and try to bring up the file we're using. I think the file is okay. I think the file is the heart disease. Okay. Yeah. So that is the data we are using. Now on the data, what we did was after bringing the data to the Google Colapse, this data, the next thing we did was we imported all the necessary libraries. For example, we import the NumPy, the pandas, the matplotlib, and the cbon. So let's run that. After that, we read the file. So this is how to read the Z file and the CSV file. So we read the CSV file. Then we call our CSV file, we call it the F. So let's run the F. And from running the F, we have this understanding that the data is 245,000 rows and 18 columns. So that is what I have. 245,000 rows and 18 columns. Now, after that, we call on some of these methods, .add, to actually check all the data. We did visual inspection on all of them. We try to look at every columns one after the other. The same way, we also went through the tail, and then we will check the shape. 245078, 245078, and after that, I'm not sure this was the actual data anyway, because it's like what I'm getting now is different from, because this was 245. I'm not sure if we got up to 245 the other time, but all the same. So we check on the info. This is the info. The info already told us a lot about the data set. Our file, we have 245078 rows, and we have 18 columns, and these are the rows. The rows, some of them are 245078, some of them 245062, which shows that we are going to have some non-values, NA. And then we have some of them that are objects, some of them are floats. I'm not sure if we have anything integer here. So these are what we get from the info. And then from there, we said these are the tasks that we want to do. Of course, instead of just putting it, because you may mistakenly want to run this, and it's going to flag an error. So instead, you can put it in the multiple quote, multiple quote, multiple what do you call it, comment. So that even if you run it, nothing's gonna happen. There's not going to be anything like an error. So these are what we aim to do. We want to rename some of the column. We want to change the mental health to float. We change the sleep time to integer, and missing values. We deal with the missing values. So after that, we check all the columns using them dot column, the help dot columns. And the aims of this is just to change some of them. We rename. And the quick method of renaming is just to quickly write the dot columns again and copy all we have from the outcome of the dot column, and then just change what we think we want to change. It's not necessary, but just to demonstrate how to change, we say alcohol drinking, we should just change it to from the initial alcohol drinking to the one that have an iron. So, and the same thing with physical activities. We also change that the sleeping time. These things are not compulsory. We are only using it we are only demonstrating so that if you come across things like that you have to change, you can easily change that. So after that, we check again the F, and checking the F is just to show that every change has been implemented. You can see the health disease, the alcohol that we changed, the mental health that we changed by putting iron, everything has actually changed. So after that, we went through changing the mental health from I think from integer to float, or from object to float. I don't know. Let me check. Let's check. The mental health was actually a mental health. Physical health. Let's check from here. Okay, mental health was float. Yeah, mental health was float. So I don't know what we were doing. Okay, mental health to float. So, oh, it was because we were using the same data, and I've actually changed everything and put everything to true when I was setting in place. So everything has actually been set. So initially, the mental health was not float, it was integer. So we changed it to float. So because we have actually dealt with this, we use this data, and because we have used it previously, it has automatically changed everything we have implemented. So that is why it may not really have any meaning now. And when we run this, we encounter a problem because the data contains non-values. So we say before we can change this to an integer, this particular sleep time, we have to do something with the non-value. So, and after that, all we did was we came here and actually checked the non-value using this method, using itmap. And by using itmap, you can get the non-value if they are not pure. But yeah, it was difficult for us to get the non-value because the non-value was just too negligible. And then we use this method instead to actually know the non-values we have. We have 16 non-value from BMI. We have sleeping. We have 14 from this and that. So we have 1 from cells. And so we were able to get that we have a non-value. Then what we did, because the non-values were negligible, we have 16, 14. So out of how many data, we are talking about 319 data here, 319,000. Let's just say 320,000 data. So which we have just only the maximum of 16 non-values, 16 rows out of 3,000 plus 300 and 320,000 and we have just only the maximum of a non-value here is 16. So we can easily remove it instead of thinking of dealing with each non-value uniquely, like saying BMI, replace it with a mean, replace sleeping time maybe with mode, replace with the age category with mode. Instead of that, let's just remove every non-value because they are so negligible. So that was why we're using this method, drop NA. So at dropping NA, we check the non-value again, and by the time you check, you discover that everything has now become 0. So after that, we can now change the this sleeping time to integer because previously we can't change it because of the presence of non-value. And now we have been able to change when we run it, there was no error because we have previously we were unable to run it, we were getting an error here. And the error is telling us that we have NA. So we can't change NA to integer. But because we have removed the NA, it's now easier for us to quickly change the sleep time to integer. So if we run again, we'll discover that everything has been changed perfectly. This one no more have NA, and the info is perfect. Now, one thing we have to do now is to look at the statistics. Basically, we have two forms of our data here. One part of the data is going to be the categorical part, and another part of the data is going to be the continuous data. So I'm sure we understand what we mean by the continuous and the categorical data. Please let's quickly answer this before we continue. Do we understand what we mean by the continuous and the categorical data? Hello, everyone. Hello, everyone.
Hello, Will.
Yeah, do we understand what we mean by categorical and
Yes,
yeah? So
categorical data or data that can be grouped
okay,
like age,
okay,
sex,
yeah.
gender.
Why the continuous data, they are things that they are numerical,
Yeah.
basically numerical. So sometimes we may have something that looks like numerical and yet they are still going to be categorical. So we have to understand all this nominal data type and different type of data type. We can quickly check using this by separating our data type, the categorical data types, and we can use this. Every float and integer, not only float, because if we check our info now, we definitely going to get both integer. Let's quickly check the info, the f dot info. If we check the info, we discover that our info comprises objects, float, object, and integer in 64. So we have one that is in 64, which will belong to continuous. The integer belongs to continuous. So we can say every continuous, every float and integer. Oh, sorry. What have I done? What have I done? I was trying to copy and paste, but I don't know what went wrong now. Okay. Okay, we check .info and okay, yeah. Now we get that we want to say that let our continuous variables be those ones that are float and integer. And in integer, we have we can be specific in 64 because of the system I'm using. You can have in 34, and you can also have float 34. So we have in 64, we can have floats, and depending on what you have here, depending on your system. So now we want to take float 64, and in 64, as our continuous variable. Of course, we have just only float and int64 here from this my description, the info. And then the only one that will belong to categorical variables is going to be the object. So we can quickly check them out and see those that are in continuous. So these are the continuous one we have: BMI, physical health, mental health. Those are the three continuous we have, and the remaining ones as were the categorical data types as we have. This is just by the way. .info. Okay. Okay, I actually checked .info twice. Let me delete this. So now, after checking .info, we already know that we have those that belongs to categorical, those that belongs to continuous, and then we want to check for our continuous variables. Initially, it was 4, 1, 2, 3, 4, but now we have changed the sleep time. We have changed it to what do we change the sleep type to? The sleep time. The sleep time is no more part of our categorical data, our continuous data. It has now turned to categorical data. I think we said we should change it. I can't recall. Let's quickly check where we have the sleep time. I've changed to this. Okay, let's run this. Then I should see the sleep time. The info again. I actually want to check what we have here. The sleep is let's see what we have for the sleep. Sleep time in 64. So I don't know why in 64 is not okay. Maybe I didn't do it properly. Let me in 64. It's supposed to be part of this outcome. BMI, this in 64 is not there. Let me just say int and see. It's supposed to be part. BMI, please, I'm looking for, there's one of our data that is missing here. Sleep time. I can't see sleep time. Sleep time, let's check. Sleep time has been changed to this. Sleep time aside in 64. Yeah. Then sleep time. Why I can't find that? Please help me to check if you can get it. I don't know. I'm not getting it. In 64. Because in this hour, we have physical, we have BMI, we have physical health, we have mental. There's still one missing. We are supposed to have sleep time, which should be the one on in 64. Sleep time. BMI, this, I can't find it. Please, if you can get it for me, please kindly check. Please kindly check it on your system and tell me what you think is going on, is going wrong with the int64. Quickly check on your own system and see if you can get it out. Because I'm not getting it here and it's an error. So please kindly check from your own system. don't know what.
So, if I may ask, please, what are we looking for? What do you want us to check?
Now, here you see we are trying to separate the categorical from numerical, and we have done that. At doing that, when we read this one you are seeing here, we are supposed to get 4 values there. BMI, physical health, mental health, because in 64, together with this, they are supposed to be 4. And that value, that particular column we are not getting is the one with in 64, which is sleep time. The sleep time is supposed to be part of this numerical. So I'm only having 3 here. It's supposed to be 4 instead of 3 because I've included in 64, we have floats and we have N64. N64 is supposed to be part. So that is what I say you should check on your system if your phone is going to bring out N64. It's going to bring out the values that belong to N64. Are you checking? Before we continue, we must bring the sleep time back to it. Okay, yeah, I think I didn't put it in the, yeah, I didn't put it in as a list. Yes, because I said this, initially we have just only floats. Let's put it as a list so that it can say the in64 and yeah, because it's not just only one. Okay, I think this should solve our problem now. In64 should be included. Yeah, you can. Okay, this is actually the problem. We're looking for this, and now we have gotten that. Sleep. The sleep time is now included. So in our we have in the continuous variable, we have BMI, physical health, mental health, and sleeping time. And the other columns belong to categorical, starting from the heart disease to skin cancer. Now, having gotten that, we already have an idea of the one that belongs to continuous and the one that belongs to the categorical. We want to run the describe. Describe, we only deal with the continuous. So by the time we run dot describe, it's gonna tell us the statistic of the dot describe. And this is what we got. We have BMI, physical health, mental health, and sleep time. So, and this is the count we have for 245, 245, all of them, they are 245, 245, which shows that they all do no more contain missing values. Now, the mean for this, BMI is 28, the mean for this, the mean for that, and the mean for sleep time. We also have their standard deviation. The standard deviation for sleep time, 1.4, standard deviation for this is this, standard deviation for that, and the standard deviation for this. And of course, standard deviation is just telling us the distribution, how widely distributed our data points are. Maybe when we get to visualization, we'll be able to just go back to this and quickly explain this with respect to standard deviation. But the other time, I try to, okay, the minimum, the maximum, 75% and 50 percentile and 25 percentile. So I try to relate them with the mean. I said the 50 percentile is supposed to be almost the same with the mean, like 27.3, and we have 28.3, which is good. And we have 3.3. Here we have 0. Oh, this is not good enough. And the same thing happens there. Then this is almost perfect. This is 7.1 and this is 7. So this sleep time is almost perfect now. And the implication of this, another thing we can do is to check minimum and maximum. We add them together and we divide by 2. 12 plus 92, let's just say 110, divided by 2, let's just say is about 50 or 55. So by the time we check the mean and the median, and it's not the same thing as the addition of maximum and minimum divided by 2. If the mean and the 50% is not the same thing as the division between minimum and maximum divided by 2, if they are not the same, it means we should be expecting outliers. Even from here, we can expect some, because if we have 3.3 as the mean, and by the time we get to 50 percentile, we have 0. The maximum is 30, while the minimum is this. They are not near at all. You see, 75 percentile is 2, and this one is 30, which shows that it's 75 percentile. So be near 30. And since they are not near, it means there are a lot, this 30 is probably going to be an outlier. Now, like this one, we have 94 and we have 31, okay? Which shows that, okay, what? If we have 31 and a 75 percentile, then the maximum should not be more than, that is 100%, should not be 100 percentile, that is the maximum, should be about maybe about 50. Because if this is 75 percentile, so that we are expecting some things like outliers there. You can see all these things, they are far more than the 75 percentile. So we discussed this in our last class. So we check if we have duplicated values, duplicate, and we have from here now we have 11,648 duplicate. All we have to do is to drop the duplicate. Before we drop in the duplicated values, we have 245,041. Let's see, after dropping the duplicate, let's see what we're gonna get. So when we drop this, the duplicate, if we run our dehave again, it's not going to be up to 245. We now have 233 instead of 245. All the duplicated values have been removed. We have 233 instead of what we are supposed to have. We are supposed to have 245, the total count. So you can see the duplicated values have been removed. What we mean by the duplicated values is that, like the what we have on number 4 here, is repeated somewhere else, exactly from the beginning to the end. The whole row of number 4 is repeated maybe at number 100, also repeated at number 400, and again the number 2 is repeated somewhere at number 50, and like that. So that is not good for our data. We have to remove the duplicated values. Okay, this is just a way to transpose. If we cannot read the statistic properly, you can use transpose to reset it, but I prefer to use to just go without using transpose. It's easier for me to read this way. So those are what we did in our last class. Now, all this description, the statistic we have dealt with so far, they are majorly of the continuous variables, the BMI, the physical, the mental, and the sleep time.
Sorry, excuse me. Please,
Yeah.
can I see the code to drop the duplicates?
Can you what? The code?
Can I see the code to drop the
okay. Let me. Okay, this is it. This is to check the duplicate value. We have this duplicate, 11,000 duplicated values. And we have to drop the 11,000 duplicated values. And this is how to drop it. It's saying check for the duplicates and drop them, only keep the first one. The first one you see, keep it, and anyone that look like it, remove every. If we have like 3 duplicated values, the first one will be kept and the remaining 2 will be deleted. So that is what it means. So if you say whether you set it to the first one or you set it to second or whatever, it's still going to be the same. So that is all what that means. So that is the code. Drop duplicates, keep first. So after that has been done, all these are continuous. We said, how do we go get the statistic for continuous variables and categorical variables? So we say all we just have to do is to still go for describe, but this time around you include objects, those ones that are objects, and you see that when we are separating the continuous are majorly of the int and floats, but the one that belongs to categorical, they are the one that belongs to object. That was why we say we include object. We only want to deal with object. Sometimes you can deal with the two, both continuous. It means you are going to include both object, the float, and the int. That is not going to be good enough. So it's better you treat them separately. So it's better you treat them separately. So now, when we come to the object, we say for the object, we get the count. If you check the count across all of them, they are all the same, so that they no more contain duplicates. They no more contain NA, rather. So they are all the same. All of them, they no more contain NA. We check for the unique. Unique is how many of these, how many answers or how many unique values are under X disease. The X disease, we have two. So we show that, do you have heart disease? Yes or no? And the one that the top frequency is no. So, and it has this frequency, 64696. So I think I've run it. Yeah. Oh, I've not run it. Yeah. It has 212481. So when you check for smoke, did you smoke? Yes or no? We said it has two values, yes or no. And then the one that has the maximum is what? Is no. And it has these values. The remaining one to complete this is going to be for the yes. And we check for the cells, and we have male, of course, male and female. We have just only two value, unique values, which we think is going to be male or female. So if it is male and female, then let's check which one has the highest frequency. We say is female with this 3,000 out of 3,000. Then the remaining one we think is going to be male. But these ones are easier for us to guess. That is why we just think it's yes or no, male or female. What about this one that belongs to categories of 13? It has 13 unique values. That is age categories. And the top one is between 65 to 69. That has a frequency, the maximum value of 24,000. So we have other 12 values we don't know that are in these categories, so we don't know. Like the race also has 2 unique values and 6 unique values. And white has the maximum value of 178 frequency. Why we don't know others, I know perhaps we're going to have black, or we don't know, I don't know what else we're gonna have. So these can only tell us the maximum values, we can only know the maximum values from here, especially those ones we cannot guess. We can, like this one, diabetes, we have no, but we have 4 unique values. Is it no? Yes. What else again? To make it 4, we don't know. So we can easily get away around that. Like all these are easier, yes or no. This one very good, this one becomes a problem again. We have 5 unique values here, and very good is the maximum. So is it very good, good, poor, bad? I don't know. We cannot know except we go and check. So the same thing happens to other. Those that are 2 and we have no, of course, we already know is going to be yes, except for this, that we have no, and we have other 3 unique values that we don't know. So I know we have no, then we have yes. What other 2 that are left? I don't know. So we can look for a way around it. And that was why we called for this. We say we can call for dot unique. The heart disease dot unique. In the heart disease dot unique, we have no and yes. Of course, if you go back and check, we now say, okay, if you want to know the number of no and yes, we can call for value counts. So that one is more helpful. So by the time you check for the value count, you see the no is 212. If you go and check from 212481, you can see from here under this frequency, 212481 is the same thing as, and that was why it said it was the maximum. No was the maximum. If you check that statistic again. You see, no was the maximum. Of course, the second one is just 20,000, while this one is 212,000. So, and from that, you actually know that no was the maximum. You check like that for every other one by checking mainly the dot unique, the dot value count rather. The value can give you more information compared to just using the unique values. So when you check the value count for sales, for smoking, for order, that is how we did and we get for everything. Now, but those ones that we are more interested are the ones that have more than just two values. Of course, those ones that are no and yes, we already know, male or female, we already know. But the one that has six categories, like this, like age, we have to check what do we have. So by the time we check the age, this is what we get. We get that the age is between 65 to 69, 60 to 69, 64, 70 to these. These are other categories and their values. Their values and their values. So you can easily see that this 50 to 54, this is the values. Then the same thing with the race that is more than just only two, we cannot guess that one. The only thing we saw was white. We don't know the other one. These are the other race we have here. These are the other one we have to make it 6 values. So we already know the race now. So we don't have to change anything. The diabetics is another place where we have a problem here. In diabetics, we say we have yes and no. And 194 say yes, and it's supposed to be yes and no, but we now have 4 different values, unique values. So we have yes, we have no, we have yes, we have no borderline diabetics, and we have yes during pregnancy. We have a problem here of like, should we leave it this way, or should we change everything to either yes or no? The one that has no borderline diabetes, we should just change it to no, and the one that have yes during pregnancy, we should just change it to yes. So if we want to leave it like this, good, we can leave it and go and plot a bar chart for it. We can plot a bar chart for that. But if we want to just change this to 2 unique value, yes or no, well, I commented this one out. We can as well just change it to this. We can change it to this. So, and this is the comment. If replace non-standard value with yes or no only, we just want to change it to yes or no. And if we want to do this, I will remove the comment. If that is what we want, I can just remove the comment and run this. But it's going to replace whatsoever we have under diabetics and turn it to just only yes or no. All what we did is that we pick that particular column, diabetic column, the same diabetics column here, and we say check the diabetics column and replace. We use mapping. This is just like a dictionary mapping. We just map and say, okay, no borderline, that is this one that has no borderline. You just copy it and paste it here and say replace it with no. That is what it means. And this one that says yes during pregnancy, copy the whole thing here, yes during pregnancy as it is written, and paste it here. Put your quote normally because it's a string and change it to yes. If we want us to do it like that, then if I run it now, it's going to replace it. Let me run it. So I've run it. It has been run. So since it has been run, if I go back and pick and recheck this the have.value count, we no more going to have the other value count, 4 value count, we only have 2 value count. So if I run it, I will run for diabetics. Because I've changed that, it will change it to just only 2 because I've mapped. I will now have no and yes. No more during pregnancy or no more borderline. That is how we can easily change what we anything in our column. So this has been changed to yes or no. If I like, I can change it to, I can even still change this no and yes, I can change it to okay. And anything we want to change it to, you can just say yes, or instead of say yes, we say okay. So we can go and change this one to okay if you like. So you just go back again and map the same way we map here. You will just come here and say anywhere you have no, changes to okay, or yes, changes to okay. Anywhere you have yes, if you want to change that one as well, you change it to anything you think you want to change it to. That is how you can change anything in your column, the unique values in your column. So now we went ahead to change to check for else. These ones are not okay. We said very good, good, excellent, fair, poor. So if there is anyone we want to change here, as we want to change poor to bad, we can just go and map it, copy the same thing, just like what we have here, just like what we have here. Instead of diabetics, you put the appropriate column names. You put the same appropriate column in name here and say replace. The only thing, if it is just only one thing we are replacing, of course, you delete the last one and just only this one, you change it to poor and change it to bad. So that is good. If that is what you want, just change it to anything you want. You can manipulate at this point. So, but since we don't want to do that, no problem. I separated again. Of course, I've done that earlier. So now this is all about what we have done. But we are saying that now we can represent all this with different type of visualization. We can just take any of the column and represent it in a particular chart. But using the chart, we have to understand that we have a continuous variables and categorical variables. There are some charts that are specifically good for continuous variables, and there are some charts that are good for categorical variables. So you don't just choose any chart, depending the charts or you choose depends on the type of your data. So if it's continuous, there are things you can use, and there are some plots that are good for continuous. If it is categorical, there are some plots that are good for categorical. So let's just go. We are saying we can use histogram, density plot, bus plot, scatter plot, line plot, and etc. We can use them for continuous variables. So for our continuous variables, of course, we already know those that are continuous variables. We can use this method by saying def.histogram. So these are other parameters you can specify if you want to modify whatsoever. These are other parameters you can specify. So if it is just only if I say this to plot the histogram, it's going to plot for all the continuous variable. This will automatically recognize the continuous variables, the histogram. That is how it works. But at the same time, you can see it plotted the histogram for the continuous variables. We already know the one we set as continuous variable, BMI, physical health, sleep time, and mental health. However, we can specify if you don't want it for everything, assuming we only want it for BMI, you can use dot notation if you like, dot BMI. Okay, before I use dot notation, this is the one we understand. Just get out the BMI. BMI. We have been using the square bracket notation. The bracket notation, if I run it, it's only going to plot for BMI. That is the only one I want to plot for. I don't want for everything. You can see it's only plotting for BMI for me. And say this is for the BMI. Then you can see those between BMI of 20, less than 20, 20 to 16 to 20, they are maybe 1,000 plus. Those that are between 40, let's just say this is 30. Okay, this is 40. Okay, it's not well arranged in a way. But this is just you just know those that have the highest BMI, they are between 25 to like, let's just say 30. They have the highest BMI, followed by from 30 to 40, they follow. If you check this, you can see about 120,000 plus have a BMI between 20 to 25. If this is 20 to 25, this is going to be 25 to 30, this 30 to 40, 40 to 50, 50 to 60. This is just the range, yeah. So you can easily check using this. If you don't want for BMI, but we use a bracket notation. If you don't want to use bracket notation, you can use dot notation. You just clear this and say dot BMI. That is going to work. So it's the same. Whether you use a dot notation or bracket notation, you got the same thing. If we need it for any other continuous, even if you want it for categorical, of course, we know we don't want to use it for categorical. Let's just copy this, diabetics, which is categorical. If I use it for diabetics, I will just say dot diabetics and run it. Is going to plot the histogram for me. Okay, this is it. We say the number of people that said yes for diabetics, they are 20. If this is 50,000, this is 25,000. Let's just say this is about 30,000. No, between 50 to 25, this is going to be about 40. Okay, let's just say about 30,000 people said yes, right? You have to be able to judge. About 30,000 people said yes, and around here will be about 40, and here is about 50. So, and those people that said no, they are about 200,000 people said no, they don't have diabetics. You can see. So this is how you can play with the histogram. You can play with the histogram. Why we put rotate, this rotate, this is just to set. This one, anytime you see figure set, it's just setting how big this is gonna be. You can see it's very big. If I want it smaller, I can put it maybe 4. Let me put it at 4, and run. It's going to be smaller, and you can see it's now smaller. If I want it more smaller, maybe let me just put it at 2 and 2, and see how smaller it's gonna be. It's not compulsory they are the same. I might decided to set the other one. Let me set the other one as 3 and run. And of course, okay, you can see. So this, you can play with this as you like. If I like, I take it to 4:5 or 6:4 and run. It's only setting the width and the length and the height. So how wide is going to be, is it? And why I set this, if I remove this, set at 45, if I remove this and run, it's still going to work. If I remove it, it's still going to work. So you can see the difference. You can see the no. The yes was written as yes and no as no. There is no any style. But if I go and say you should set it to, if I go back and set it, you will see the difference. I set it to 45. That is to rotate it through x-axis at angle 45. You can see it's slighting here. You cannot understand the implication of this until when you see the one that has a multiple labeling. That is when you will understand. And even if you don't have anything here, by default, it's going to get you a default chart. Let's run. You can just play with this. You can just play with it. You can see it's getting you, that is the default. Can just play with it. It's getting you the default. Yes, no. The other thing you are setting, that is what you only want to play with. If you like, you set the color, you set anything you want to set. So that is what this one does. And this does show is here just to show this. If this does show is not there, well, because this is a Google Colors. Google Colors might see displays, but if it is not in Google Colors, okay, yeah, because this is Google Colors, that is why it can still display. It will never display as me it's not a Google Colors. For example, as me you are in you are in Visual Studio and you don't put this. Oh, if you are in Visual Studio and you don't put this one, is it Visual Studio? I want to say yeah, Visual Studio Code, and you don't put this, it's not going to print it out for you. You will not see it. It will just run, but you will not see the charts. So that is all about it. When you get home, you can plot this. You can just play with this one as you like. If you don't want diabetics, you can go back again and pick anyone you like. Let's pick race. Let's pick race and see what is in the race. Histogram. Though histogram may not be a best thing for a for categorical, but notwithstanding, let's just use it. So you run this, the race. Now you can see what we have in the race. Of course, we have the highest one, which is about if this is 755, maybe 756. All we just want to show here is that this has the highest one, that is why you can now see the implication. Yes, this is what I actually want to show. The implication of using the rotation. Let me remove the rotation and run. You will see the problem. Now, it's what you can see that we cannot get the distinct labeling here. The Alaska, whatever is over, has overwritten the American or whatever is here. We cannot really see what we have on this column and what we have for this and what it's only this white, black, and Asian that we can see properly. Every other one we cannot see them properly because they overwrite each other. But if you go back and set the rotation now, by the time that is just the major reason for setting the rotation, you'll be able to see it distinctly. You can see. You can see now that we now know what is here. We know what is here. This is this. Okay, you can read it. This belongs to this. Why this belongs to the last one. So that is the reason why we just set the rotation slightly. But there are a lot of things you can still do with this chart. You can set the name for this axis, the horizontal axis, the vertical axis. Those are things we can do. In other charts, you will see. After that, we can also treat what is known as, okay, before then, I said we have to do some stuff. Yes, let's go back to the normal histogram. Let me not specify anyone here and run so that we just treat the 4 continuous variables. These are the 4 continuous variables. You can see the 4 continuous variables. You can see these are the 4 continuous variables. Of course, we still have some problem. We have some stuff to set if we want to set them. We only want to deal with the continuous variables. So let me quickly pick them one after the other, and BMI. And okay, before then, let's run dot describe again. The F dot describe. Describe. For the continuous variable alone. I want to use this to explain the implication of our statistics. If we are using histogram to explain our statistic, let me just treat them one after the other. BMI, BM high, BM high, one after the other. Oh, what went wrong? Okay. B dot BMI. Now, if you check this statistic, you will see that when we are dealing with the statistic, you see we have the mean is 25, while the median is 27. There is something this is telling us, that if this and this look almost the same, the shape of is going to be normally look like being normally distributed. And a normal distribution is going to be like where we are going to use density plus to explain again. But when you check, you will just check the shape. You can see you have, if we are to draw a graph on it, it's going to be like a parabola like this. It goes up and down like this. And you have a tail along here. It's going to be like this, like a mountain. You understand? You can see is taking the shape of a normal distribution. So you can see this. Let's check another one that we think can take a shape of a normal distribution. I think we have 8, this one, we have 7 here, and we have 7 here. So let's plot for this and check what the shape looks like. Sleep time. Let's check the shape. We are only dealing with the statistical aspect as well. So when you check the shape, what happened again? Okay, I put space here. What happened? What did I do? Or did I copy wrong? Okay, if it's not working, maybe I should just put it and use this. You know why it's like that? Okay. Sometimes you can see I use this, maybe because of this Ivan I put, it doesn't want to work with Ivan. That was why I decided to use bracket notation. If you check this shape again, you can see this shape. It's just like eel. Like if you start from here, you start like this, and you draw over the center, you can see it's just like eel. It looks like almost normally distributed, because you can see that the mean and the median, they look almost the same. This is 28 and this is 27, which is good. This one again, this is 7 and this is 7, which is good. But if you check for this one that is 4 and 0, and for this one that is 3 and 0, the shape is not going to look like an hill. Let's check for the physical health. You will see the way it looks like. This is how to know the data that is from here. You can actually know if your data even from the statistic. I already know those that will look like being normally distributed and the other one that will not look like a normal distribution. So let's check for this. You can see this. It doesn't look like an hill. It starts from up like this and come down. You can see like a bell, what shape is this? Which shape do we call this in economics? Like this, and now goes up again. You can see the shape. Like you can say it's like you. If you are to draw along the borders, it's like you. It shows that the data is not normally distributed. The being normally distributed has its implication. It has an implication in the modeling. So, but we just have to understand when it's not when you see your data, you can actually know if the data is normally distributed or not. If I use this one again, the next one, if I check for this, it's not also going to be normally distributed. You can see, it's almost the same thing, just like you. You can see it's like this. You can use it to know the data that are normally distributed. If your data is not normally distributed, like this, there are things you can do before you run them into a model. But since we are not yet dealing with model, so let's just continue with our visualization. Anyway, this is how to check plot our histogram. There are other parameters you can set, like the title, the y-axis label, the x-axis label, the title, and lots. There are lots of other things we can do. Now, another kind of plot we can plot instead of histogram, you can check on how to do those other things. Of course, some of the chart already have them. So when you get home, you can just copy from some other charts and try to implement. Like this one is what we call the density plot. That was what I was trying to illustrate here by drawing like this. I was trying to illustrate the density plot. Now, let's go back to density plot. You will see that by the time I draw the density plot of BMI, this is for BMI. The BMI, I said plot time density. This is a density plot. The density plot is already showing that you can see, like it's normally distributed. I told you it's going to be like an eel. It's normally distributed. You can see. And normally, this part to this part, it is very perfect. But to this part, you can see that it looks long. telling you that there is an outlier to this side. Normally, it's supposed to just stop here and to form a perfect normal distribution. But by the time you see it, and if you're coming long to one side, it's showing you that there is an outlier towards that distribution. And by the time you check your statistic again on BMI, you can see that you have 94 here, and you have the 75 percentile to be 31, which shows that there is an outlier towards this maximum size. Rather, that's why it's going to. If by the time I draw this one as well, it's also going to have the same structure, because this stop at A and it's go as far as 24, which shows that there is going to be an outlier towards the 24. And that is why it may not just be a perfect normal distribution. Anyway, there may not be a perfect normal distribution, but there is a way to control this your distribution to make it perfect, to make them perfect. There are different techniques you can use before you set them into a model. Now, I will check that. We also want to check for other ones. Yeah, we have checked for BMI. Okay. This for BMI. Okay, this stay for BMI. The only thing I did here was to label PLT. This is what I said you can do. And on the other one, you can set for S label, the Y label, and whatsoever. So the same thing, you can just copy the code and go and put it on the fourth one. And you can see here, I now have BMI, and here I put count. If I like, I can put frequency here and put BMI here. It means frequency against BMI. You can see the tail is long again, the same thing. But the only difference between the first one and the second one is that this density plot I plotted here is plotting it from this density plot is plotting it using matplotlib. Of course, in our import, we imported matplotlib, and we also imported Seaborn. We can import, we can plot through matplotlib. We can also plot through Seaborn. So there are some plots we just decided to use Seaborn. There are some you decided to use matplotlib. So in this one, we use both matplotlib and Seaborn. For the first one, it was Seaborn. Matplotlib rather. So, and the second one is a Seaborn, and you can see the only difference is just maybe the way they look like. You can see this one really tells us that you can see this is really showing that this moves towards this part, telling us that there is an outlier towards this part. This is not a way of the best way of detecting an outlier anyway. We still have what is called bus plots to detect. But from here, you can see this tail and this tail, they are not the same. If the tail has been the same and they just almost the same, this one just stop here. Why this one stop here? It should have been a good distribution. You can see a normal distribution, but it's not very normal, but it's better. So if we plot for other one, okay, before we go, let's plot for another one that we say they are not normal distribution. They are not normally distributed in our in this other one. Of course, this BMI and sleep time, they are normally distributed. If I plot for sleep time as well, let me just copy the sleep time in time. It's like if I copy the sleep time and check and plot for that, it's still going to be the same. But I guess the sleep time is also going to give me the problem if I don't put it as this notation. So most of the time when you have all this hyphen, that is why it is preferably when you are naming, you keep them together so that you can use dot notation. If it were to be like this, sleep time, it would be easier to use dot notation. But if they have been separated, they have a space or anything, you cannot use a dot notation. So I want to plot for sleep time. It's almost going to be a normal distribution. You can see it goes normally, this one normally, this one normally, like that, and now have a long tail. This one also now have a long tail. So the long tail, you can see, you now have some distortion here. You have some distortion towards this area. You have some distortion here. If you check it properly, there's going to be some distortion and some long tail. And here you have some little distortion here. This is showing that you can see that there is a little distortion here that you have, though it's almost normal distribution. If you check every one of them uniquely, they look like normal distribution. They look like normal distribution. But let's look for those that, let's check for those that we said will not be a normal distribution. You will see the difference between them. Now, they are not going to be a normal distribution because even from their statistics, these two, from the statistics, look at this, look at the mean. This is the mean 0, and look at the median 3. Look at this 4, and look at this. So they are not normally distributed. So let's check. You will see the difference between the charts. Let me just change this and run. Okay, I hope you can see. Even from here, you can see lot. You can see. You can see. So telling you that this is far from being a normal distribution. Look at this place. Look at this. So these are things you use to check those that are normally distributed. Let me check for another one that I think will not be normally distributed. If I copy from here, physical is not also not normally going to be distributed. You can see that this is quite different from, it want to take the shape of sleep time, but the sleep time is not like this. You can see that the sleep time is better. It's far better than what you have here. You can see this. In the case of the sleep time, it was going, everything was going normally, except towards the end when you have little distortion. So you can see the difference between them. So this is far from being a normal distribution. Let me do for the other one. So if I run this, you can see it follows the same thing. You can see here, it's far. You can see the distortion here. It's far from being a normal distribution. This uniquely will have been a normal distribution. This uniquely will have been a normal distribution. This uniquely will have been a normal distribution. But this is not even getting down. You can see you now have lots of distortion here, which shows that it's not normally distributed. So these are the implications. These are the things you can actually get from your visualization. You need to understand what every visualization are used for. I can use the density table, density plots. I can use the histogram to actually show that the data is normally distributed or not. So apart from using that, I also have another type of, in this first one, we were using matplotlib to plot the density plot. But in this one, we are not using matplotlib, we are using Seaborn. You can see we use, anywhere you already see SNS, you are using a Seaborn. You can see you are using a Seaborn here, SNS, showing that this is a what do you call it? Seaborn libraries that we are using. So you can as well copy all this. If I copy it to the other one, it's still going, whether you use this PLT is coming from matplotlib. You can see we say import PLT and matplotlib libraries as PLT and import Seaborn libraries as SNS. We can use them together. You can see we are using both SNS and PLT together. So that is how to do some little design you want to do. And all these figures you can keep changing. I just, I put I commented it out because if I like, I can remove it and now be changing. If I like, I want the shape, maybe I want 2,4. It's going to be very small, 4 or 3. If I run it, it's going to be small. You can see how small it is now. It's going to be small. If I want it bigger, if I want to keep it to a default, I can just, if I want a default, I can just put comment. If I comment it out, it's not going to give me this, it's going to give me the default one. So that is exactly how to do this. So you can see. Now, another thing we want to check is box plots. box plot is very appropriate for checking whether our data is having outliers. Yes, it's having an outliers. So of course, we have to use this one to check whether we have an outlier. This one we can use to check whether we have a tail to this place is not too long. You can see this tail is not too long towards this side, which shows that there is an outlier towards this area. And if you go back and check your BMI summary, you can see that the maximum from the summary is 94. That is why the tail moves towards this side on the BMI. You can see it moves longer and it goes. Assuming it just stops there, then it's going to be normally distributed and there will be no outliers. But if you check using box plot, you will actually see that there is an outlier from the plot. This is how to plot it. The same thing happens to all these. If you like, you put it. If you like, you don't put. This one, H is only showing that horizontal. If you want vertical, you put V. So for BMI, this H. You can see it's saying that for this BMI is showing you so many things. This is the upper limit. It's telling you the upper limit, the lower limit. This is the lower limit, the upper limit, the lower limit. Look at this. Everything you have under your statistics here, all this we have in the statistic, the upper limit, the maximum, the minimum, the 75 percentile, the 25 percentile. Let me just call dot describe again so that I will not be moving, so that you can understand what box plot is actually telling us. Let me just bring dot describe here again. The f dot describe you can run this as many as possible instead of scrolling up again. In the dot describe, we have the minimum, the maximum. Of course, in here, we are going to have the minimum values and we are going to have the maximum values. By the time you check, the minimum values from here is around, I don't know, maybe we should say this is around 10. I'm not sure. No, you just have to, This one, let's say the maximum value we have here, this should be around the maximum values. That should be here, okay? That is what it should be. But you have other maximum values. You have other values that are going to be set to be outliers. If you check, you are going to have a maximum value that will be more than what we have. This is what it is expected. Here we have the mean. The mean is expected to be around, I don't know, this is 30, right? If it is 20, this is going to be around 30, right? This is going to be around 25. I'm not sure. So let's just say 20 something. Let's say 25, 26, 27 here. That is going to be the mean, the middle value here. Now, if you have the middle value here, you are going to have the yearly percentile, 25 percentile here. You are going to have the 75 percentile here. That if you go back and check, those are what corresponds to, you see, the mean value, the 25 percentile is around, okay, the 50 percentile is about 27. So if you check this, the mean, this mean here is saying that this is 27 here. This is 27 that you have here. Now, it's also telling you have the 25 percentile and of course, the mean value is 50 percentile, that is 27. And before it, we have 25 percentile, that is 23. And after it, we have 31. Those are the boundaries. We have 23 somewhere here. You have 27 somewhere here. You have 31 somewhere here. I'm not sure if 31 I said. Let's check. Yes, we have 23, 27, and 31. Those are the boundaries you have here. 23, 27, and 31. Those are the boundaries that you have in this chart plot. You have those boundaries here. Apart from those boundaries, what it is expected to be the minimum, if you have those boundaries, should be somewhere here. And what is expected to be maximum is going to be somewhere here. Because I told you earlier that if we are saying that this is 75 percentile, then the maximum should not be more than around 40, 50, around 50. if the 25, if this is 75 percentile, but now we are now have 94 percentile, which should be an outliers. Because normally, if you check the maximum, if you check the 75 percentile, that is 31. Okay, you check the 25 percentile. The minimum should, okay, we already have the minimum, that is 12. If this is 25 percentile and it's 23, I think 12 is still good to be a minimum for it. But now, if you check the 75 percentile and it's 31, then the maximum, the 100 percentile cannot be 90. It should not be more than around 50. That is what this is indicating. That, okay, if this is 75 percentile, then the maximum should not be more than something around here, maybe 40, 45 or 40 something here. Any other thing after it, even though in our statistics, we have so many things after it that we even have up to 90, all of them are going to be said to be an outlier. And that is why when any other thing after it, from here to here, you have a lot of it. All these columns, all these things, they represent every row. They are all outliers. If you have just only one, it means you have just only one outlier. If you have two, you have just only two out. But if you check now, it's many. So all of them are going to be said to be an outlier. They are already more than around 40 something or 50 that we are expected to be the maximum. And around 17 or something that we are expected to be the minimum. We have some little of them that are just around this. And they are just more than, and they are said to be also be an outliers. They are too small, and there are some that are too much, they are too large. So this is how to interpret a Bose plot. You can treat for other ones like physical. All this we have a lot of outliers because the one that are even better, they are the sleep and the body mass index. You can even see in the sleep, someone is saying sleeping for 24 hours, which is not possible. It's going to be an outlier. From this statistic, if we have the 50 percentile to be 70, and the maximum in the 75 percentile to be 8, then the 100 percentile should not be more than 9 or 10. Should not be more than 9 or 10. Now we are now having 24. So by the time we check for the for the bus plot, you will see that it's going to tell you that the maximum should not be more than around 10. Let's check. How can you sleep for 24 hours? So let's check. So by the time we check for this, you see, it's telling us that, okay, the maximum is more than 10 anyway, okay? If this is, it's telling us that if we have the 50 percentile to be 7, and we have 75 percentile to be 8, it means we have 6, 7, 8. Yes, 25, and the minimum here is 1. 6, 7, 8. 25 percentile, 50 percentile, and 75 percentile, 6, 7, 8. That is what this represents. 6, 7, and 8. Here. 6, 7, 8. If you have 6 as the minimum, as the 25 percentile, then it's telling us that if 6 is the 25 percentile, that's starting from the minimum should just be around maybe 3. And the same thing telling us that if the maximum, the 75 percentile is about 8, that the maximum should not be more than 12. That is what 11, 12. That is what it's telling us. Anything that is now more than 12 and anything that is now more than around 3 will be said to be an outlier. So anyone that says I sleep less than 3 hours, these are the only 2 people here that said maybe that said they sleep less than 2 hours in 3 hours. I don't know what the hours that is going to be. If you check, if this is 0 and this is 5, let's just say this is 3. So anyone that says they sleep less than 3, they are going to be said to be, you can't be sleeping for 2 hours in a day or even 1 hour in a day. So they are said to be an outlier. And according to this, he's saying if this is 11 and this is 12, or well, let's just say this is 11, right? Yeah. He's telling us you can't be sleeping more than 11 hours in a day. If you sleep more than 11 hours in a day, then you are an outlier. Maybe you are in coma. Maybe you are dead. Maybe you are dead. So that is taken to be an outlier. You can see. So, and if you count it, those are the number of outliers that we have in this. Unlike the other one, it was much anyway, but this one is easier to get. But if you check for the other one like physical, I guess all this one will be much because it's not even normally distributed. Let's check. We are going to have a lot of problem in this one. Let me put it here and run. You can see this. You can see it's not, we can't even get the minimum. You can see the minimum is not even defined. We can get the 20, in fact, we can't even get the mean. You can see, and if you see, there is no mean indicated. The mean is indicated as part of the 25 percentile because this is 0, and the other one is also 0. So it's giving us a complex problem here. You can see, if you go back to that statistic, you can see that this, even the mean is 0, the minimum is 0, the 25% is 0, everything is 0. And even if you go back to this one, it's still going to be the same. That is why the shape is not giving us the normal shape that we are supposed to get. So this is giving us a lot of problem, even towards the negative, towards the minimum. But towards the maximum is easier. We have some little things. We can easily set that one towards the maximum, but towards the minimum, we have a lot of problem. Towards the maximum, of course, the maximum we have here, we have some 30 here. From 2, we have some 30. And those that are more than, okay, maximum, if we have about 2, the maximum should not be more than about 3 or 4. So that is what this should tell us. If we have this at the maximum, which is said to be about 2, then if you have 75% rather, which is about 2, then it's telling us the maximum should not be more than 5. Any other thing that is more than 5 is set as an outlier. But in the case of this one, we have a complex problem because everything is set to be 0. The mean, the median, the 25 percentile, you understand, everything is set to be 0. That's why we are unable to read anything towards this side as either outliers or not, depending on the distribution anyway. So that is how to plot a bus plot and interpret a bus plot. So I will just keep it at sleep time so that when you get to your Google Colab at your own study time, you use the sleep time to check, and you will use it to understand what it means properly so that you can. The bus plot is very, very important. So you can see this one is easier. You have both outliers at this side, and you have just only 2 outliers at this side, and these are the number of outliers at this side. So this is very easy. It's very easy to interpret. So you can, the 25 percentile, the median, the 75 percentile, the maximum, the minimum. Although in your table, you have a minimum and maximum, which is not the same thing as what you have here. It's saying that maximum is too much. If you have this as 75 percentile, it's telling you as 8 percentile, it's telling you that the maximum cannot be up to 24. That 24 is said to be an outlier. So maybe this is going to be the 24 at the maximum, not even. This is the 24. The last one here, my cursor is pointing at, is the maximum. That is 24. Every other one that is less, and they are between these values to that, they are the set outliers. Scatter plots. We have a scatter plot. In the scatter plot, you use scatter plot as well to for relationship between 2 continuous variables. For example, you want to check the relationship between time and day and temperature. Maybe you have taken the temperature between Monday to Friday, between Monday to Sunday, and you want to check the temperature and against the day, whatever. Or you can use a scatter plot. You can use a scatter plot for that. So though we may not really understand this as much, but the same way, all this is nothing. All this one is nothing. It's just the title. All this one. If I remove it, it has nothing to it. It's only adding the title, the vertical, the x-axis, the y-axis, the title. This one also means nothing. It's only setting how big it should be. How large, if I like, I can say 8, 8. If I like, I can say 12, 16. If I like, I say 4, 6. Anyhow, this one, the same thing. The only thing we are plotting here is this scatter plot. And this is how scatter plot looks like. And the only scatter plots we have plotted now, we are only plotting BMI against physical health. If I like, okay, let's plot it against, let's choose another parameters. If I plot it against, let me just pick any of the parameters here. Let me plot it against diabetics and see. I want to plot one of them against diabetics. That is how you will play, but you really need to understand what you are plotting. This is plotting BMI against physical health. But let's plot again BMI against diabetics and see. If I plot it, this is what I have. It may not really make sense. You can see it does not really make sense. So in some cases, it may not really make sense to you. So you have to plot a chart that you can explain. You cannot explain it. You don't really have to plot the chart. Anyway, this is also possible charts you can plot. You can actually indicate what we did here is like plotting BMI against physical health and indicating anyone that has anyone either that has heart disease, like plotting three things together, and anyone that has heart disease or not. So, and in heart disease, you have yes or no. So plotting physical health and BMI, we now set it like out of the physical health and BMI, anyone that has heart disease, put it as yes, let the color be this, and anyone that has heart disease that has no, let it be blue. So if you look at it, you will see that many people does not really have heart disease when you check, because the color blue is more than the other color. So these are things you can set. This is where you only set it. You also set that when you want to plot multiple bar charts. You also set this HUE. You also set it. So if you set that, it's going to give you something like this. That will help you to interpret the relationship between the three different columns. So now let's explain the line plot. Line plot majorly meant for something the same way we plot a scatter plot. We can also plot a line plot. But for this purpose, since the data we have is not the type we can use a line plot for, in fact, the same thing is not even the type we use a good scatter plot for. We generated a data here, and this is the data. We generated data, and this data is named as date, and another data generated as sales. So we form the data, and from the data, we already have that the have, we set it as data frame, the have sales. If you like, you can plot it's different from the data we are using before now. We only generated this one so that we can really understand what we mean by line plot. It's majorly meant for things like times. For example, we want to check the performance of students over years, maybe in an examination. Okay, you can say, okay, in 2025, this is the performance of the student. In 2020, okay, in 2020, 2021, 2022, 2023, 2024, or you want to say financial statement of a particular, depending, I don't understand the financial terminologies. You can say, is it GPR or GPD? I don't know what the financial statement you people used to put. So you can say this of a particular, maybe of a country against particular year. In 2019, what is the gross domestic something like that? In 2021, what is the gross domestic? I don't know what you call it. And 2021, 2022, you can use a line just to show the progression. You can see when it's falling and when it's rising. The same thing is what we are doing here. So, and to do that, you already understand the kind of data you can use that kind of the line that is appropriate, very appropriate. So you have to check which data you have and which plot should be appropriate for you. You don't just choose a data you like. And here, I already told you this is nothing. All we did here is just to form a data that is different from what we are using before. It's just to form a data. So we formulated the data Okay, we can print. Now we now have another data frame, which is the F sales. So you can check it out, you can print it. If you have actually run this, it's going to give you another column, which will be date and sales. The one that you have a date and sales. So we want to print the date again, the sales against the date. So, and what we did here is nothing. This one, you can remove it. It's just to set the figure. And even the same thing with all this, you can remove them. The title, the plot, the S label, the Y is just, and this one, you can even remove it. This is just a rotation. You can remember we plot a rotation the other time. We said our S rotation. If you are using Seaborn, this is the one you use. If you are using what do you call it, Matplotlib, the other time we use Matplotlib. This was the one we used because we were only using Matplotlib. Okay, we use this one to set our rotation, and the rotation we set, of course, we still remember this. We want to make it slants so that we can see it properly. The other time we're able to see the implication. So, but if you are using Seaborn, you don't use that. This is what you use to set it. If it is Seaborn, in Seaborn we use this rotation S tick. We set in our S tick, we use this rotation is equals to 45 to set it. That is rotate through 45. And this is actually what we are doing. Just rotate it through 45. If we do not set the rotation, it's going to put everything together. Let's remove the rotation. If we remove the rotation, you will not be able to read. It's going to overlap. Okay, I can even just comment it out if I like. Let me just comment. Yeah, and run. If I run it again, you will no more see the rotation there. Okay, you can see we cannot read anything here. You can see the only thing that can help us now, if you don't want to to set the rotation, is to increase this maybe we should increase this to 16 by 16 or 12 by 16. Maybe that we add 12 by 16 is going to enlarge it, and that may be able to help us to, okay, you see, it's now enlarged. Okay, now you can see it's better. You can set it. You can still do that. So you can just play, you can just play anyhow you like with the data, with the chart. Let me return it back to what we have before. Now I set the rotation back. Okay. Now this is what we have. So you can see and this date is the sales. If you like, you call this frequency, just call it anything you love, you think is appropriate for it. So this is how to plot the line plot. And it is only appropriate to things like time series. You want to see how things grows, or you want to see maybe an investment. In 2020, what we invested, in 2020, in 2021, 2022, how things go with time or grow with time. So you can use a line plot. You can use a line plot for that. The same thing goes with scatter plot. The only difference between scatter plot and line plot is just that in the line plot, in scatter plots, like you do plot in a graph, you only plot it and say S, what you have here, you plot what you have here, you just put a star, you put a star. But now if you want to turn it to line, you now come and draw line over them like this. Okay, when you draw line over it, it becomes a line plot. When you don't draw line over it, it is a scatter plot. You can see the only difference is that all these were joins together. You will see we set a parameters here. We say marker. The marker here was set to O. If you like, you can set this one to anything. If you like, let's set it to maybe a mark, so that we just be marking it. The O is what it was using. You can use any other thing. What can I use? Let me use this. If I use this and I run it, it's no more going to be using okay. You can see what it's using. You can see it's showing the mark I put. So if I don't put anything, it's going to use the default. So if you like, you can put star. If I put star here, it's going to be using star to indicate. Let me just put asterisk. So if I run that, It's going to be using asterisk to indicate. You can see using an asterisk to indicate the point, but we'll use O to. So you can play with this as you like. You can see. So it's just a method that you choose to. Now that is scatter plot and the line plot. So the only thing you just do is just to be copying, you copy, and then you have the x-axis and y-axis, what you want to be in the x-axis, and what you want. This is the data we are using. That is the df we are using. The data is this. Assuming we are using the other one we are using before, we are just going to remove the cells from it. And then, of course, you set whatever you want to set at the x-axis, the date in it, and you set the cells in it as your y-axis and x-axis. So, but in the other case, you can use the f dot date, the f dot 6 to indicate the y-axis and say and x-axis, a particular column. And of course, you already know how to select a column. So the same thing happens with the scatter plots. So another plot that we can use, of course, we have already drawn heat map. We already know how to use heat map. The other time, we use heat map to show the non-values. Yeah, we use heat map. This is heat map. We have been using it for some times now. Heat map, cbond.heatmap. So this is what we want to plot. The f dot is null, the non-value. That was what we want to show here. But heat map, we can also use heat map to show maybe correlations. We can actually plot the correlation using heat map. Let's see, maybe between the numerical values. We have our numerical values. We can show the correlation between them using heat map. So let's go back. Yeah, this is heat map. We have, of course, earlier we already defined something like this: continuous variables. Yeah, and we also define what we call categorical variables. So I want us to just plot each map showing correlation between them. If we have correlation between them, this is how to run that. As no attribute correlates. Okay, let me check. What happened here? Which index? Let me plot the f first. The f that we were using before, and see. Oh, then what is wrong? We should be able to plot the heat map. Oh, could not convert string. No. Yeah. Okay. Let's now do for the help of continuous variable alone. Since we want to deal with continuous variables, I think this is the continuous variable we use. I hope this works this time. What's the problem? I think we have run the continuous variable before. Let me check for continuous variable again. I thought we have run it. I can't get the continuous variable. Please check I think we have run the continuous variable before. Kindly check.
Yes, we've run it.
Aha. So was it continuous variable we call it? Check for me.
Yes, continuous underscore variable.
Okay. So I don't know. Let me check if there's something wrong with it. Let me quickly check and see if, because we should be able to run correlation for our continuous variables. We should. We have our details. Okay, we should be able. Let me check if I have to round up some stuff for the continuous variables. Maybe that one has let me use another code. I have another code I can copy, but the only problem I have now is if the continuous variable was I used, if the continuous variable was what I use as the continuous variable. Coming. Coming. Okay. I'm still check. Okay. Sorry, I'm coming. This let me check another code I have. If I set the correlation of this and I set it to continuous variable, this is the continuous variable. Yeah, I think continuous variable was even standing on its own as the f. Yes, I don't think I even have to put it as the f. I think it was standing on its own as the f. Let me.
Yeah, it was standing on its own.
Please, I hope you can see me back.
Yeah, yes. It was standing on its own.
Okay, if it's standing on its own, I think we should be able to plot it directly, but okay, let's see if this is gonna work. If that is not working, of course, let me leave this for now. Let me use this. Index object has no attribute, correlate. I don't know why I'm not able to use a correlate for it. Let me copy the error and check. Sometimes when you have an error, you can just copy your error and check on, let's quickly check the error out. Let me see the, okay. This is what I got. I got that I am supposed to round it up to 1. Some of them have to be rounded up. Okay. Let me see if I've not used that. Okay, I think I was to round it up, but okay, it was rounded up already. Yeah. Let me check. Correlation, numerical does this. Let's run and see if it's gonna work. It's not still working. Okay, I don't know what's the problem. Okay, we're gonna leave this and maybe later. Okay, numerical the have. Am I having numerical the have? Correlation is equals to this. Equals to the one significant figure. Heat map. Okay, I set my correlation already. And the correlation is numerical. No, are we using numerical or variable? I think we were using variable, right? I think we were using, the problem is that I'm not even sure. Okay, I think we were using continuous variable. Let me see. If we cannot get it, we'll leave this. So when we get to machine learning, I will definitely still talk about correlation. It's not working, okay? Since it's not working, let's just leave it. It may just be a single error. So I know I still have correlation I have to talk about anyway. But now, apart from numerical data, we can also plot things like pie chart and bar chart for categorical data. So, and this is how to go by it. If we choose this particular one, the earth disease, and we count it, check.count of the, for example, in the earth disease, we are going to get yes or no. So we are going to check the size for the yes and the size for the no. And the size dot index, that is the index is going to be yes or no. The values is going to be the values of the yes or no. So we plot them against each other. That is what this one is just saying. I understand. I hope you understand what this means. We are actually checking for the dot count. We have checked this earlier when we were checking. Let's quickly do that so that you can remember again. When we were checking for, let's quickly check this and run. If I print this size now, you will see what the size represents. You can see what the size represents. No is this and yes is this. Okay, that is what the size represents. That is all what we have here. But if you now come and see this size dot index, the index is no and yes. And the size dot value is this and this. So we are plotting this index against this value or these values against this index, depending on the one on the y-axis and the other one on the x-axis. That is what we are just plotting. So that is all it means. We already understand what this size represents now. And in that size, we have both the index and the value. Because we are going to say yes, 5 people, no, 3 people. The yes, we now want to print yes, no against 5 and 3. So the index is the yes and no. The values is the values in front of yes and no. Those are what we are printing as our x-axis and y-axis. That is all. All these ones, they are just size. They are not compulsory. You can remove them. Even this one, they are not compulsory. You can remove them. Even all these ones, they are labels. You can remove them. I call this one responsive, that is yes or no. I call this one the label, the Y label, I call it as this, and I call this one as disease pie chart or as disease against the rest. It depends on how you want to plot that. So if you run this, this is what you get. It's a bar chart. You can see all this, the chart you put, all these things you put here, the earth disease, you can remove it. You can play a lot. You understand where you get them from now. You can just go there and play around it, anything you want to format it to be. You format it. You can even say title is title, and then you put column and just says here. If I like now, I can say the title. I want to call it title, or I say figure. Yeah, I think we are used to figure, and you do like this. Of course, this one have to be part of the figure. Okay, you do like this and you run it. It's just going to tell you that the figure is that. Okay, instead of just saying, okay. In fact, if you like, you can say figure 1.2 here. Figure 1.3, 1.4. Anyhow you want. You can just play around those stuff. If I run it, you can see figure 1.4. Heart disease, this and that. So that is just a way to plot. You can plot for everyone. The categorical, just pick them one after the other and plot for them. I want to plot for another one, it's just a matter of changing the heart disease to whatever I want to change it to. I just go there. I don't want to plot for heart disease. Maybe I want to plot for race. I think we have something called race here. I can just go there and pick the race. Check, okay, since I can't find it, it's far somewhere, it's far away. I can just come here and say, let me just print the f dot columns so that I can see all the columns I have again to know what I can plot. Let me just copy what I have up here. Let me just copy the code. Every other thing is just copy and paste. Once you just understand, you just copy and paste. I just copied it. If I copy this now, I can just come here and paste it and paste. It's just copy and paste. Now what I want to plot, you just check any of the columns. I want to plot for race. Let me see the race. Why I have to, I want to be sure of the spelling, whether it's capital, small, whether it has any other thing, you have to be sure of that. Race on coming. Just want to admit 2 people joining us. Okay. Now, let me go back. So I have the race. I just remove this after the race and put race. And the same thing. The only thing I just have to change is anywhere I have the at disease, I can just say race, race bar chart. Anything I want to call it. So, and run, it should print the race for me. This is for the race. Oh, now the problem I have here, there are 2 ways to solve this problem. You can see I can't read. You see that I rotate through 45 degree, or I set this one, I increase this. If I like, I can increase maybe to like 8, 12. That may be good. If I say 8, 12, or 10 as a scale, I run. That may be good. It's not still okay. It's not still very good. So I can keep on increasing until I have a very unique one. Let me increase it to like maybe 14. Let me just increase that one. I think this is the only one. Let me increase this to 16 and run. Oh, I was actually increasing the particle. Sorry. Let me say 16 against 8 or even against 6 and run. Yeah. You can see it's better. It's better this way. You can see this now. It's now very distinct. So I might decided to do it like this, or I might go and run the rotation if I like. Okay, it's like I did the same thing here. Yeah, it's the same thing. It's raise, raise, raise. If I run it now, this is now raised with the angle rotation to 45. You can see anyone you think you love. But this is another one. This time around, okay, no, before I continue with this is another type. I can just copy this, take it back, and then reduce the size. But this time around, I want to include multiple bar chart, like race and heart disease. How many of these race has the heart disease, yes or no? So I want to, like a multiple bar chart, we put two things here, unlike before, that you just check the difference between the first one. When you are plotting for just only, you can see I only have, this is the only thing I have in the plot, okay? But by the time I want to include another thing, you can see, now that I want to include another thing, I have my DHEV, I have my race, and I have my heart disease. It's like I'm plotting two things together. So it's different from the other one. It's different from the other one. Okay? So now if you check this one, I was using bar plots, right? And in this one, it looks almost the same. I'm using count plots. You can see it's another plot, but almost the same. But this time around, I'm not only using plotting for race, I'm plotting for both race and the art disease. Like I want to plot a multiple bar chart. You can see for white, you have this race, you have this, those that says this yes or no, that they have heart disease. In the white, you have many of them say they have heart disease. In the black, we have little. In the Asian, they don't even have anyone with heart disease, others, and things like that. Oh, this one has heart disease, small portion of people. So, and you can see this one indicating the one that says yes and no. Those are the multiple things you can try. You can just go and change all the columns and see whatever you're gonna get. So that is how to, like the same thing we do. If we don't want it this way, we can just remove the rotation. You can as well remove the rotation and change the size. You can just change the figure size. So this one is not having, just copy the figure size you have here. This one, just copy this one and put, and then adjust to your taste, and then you're gonna get it perfectly done. All this response, you can change it to anything you want. So that is the same way I still have a bar plot. Then these are things you do with bar plot, the count plot, and you can see this one also a multiple bar chart. You can see this one is only telling us, is only plotting heart disease against smoking. The people that have heart disease and those that said they smoke. And this data is just our DF, the whole total data frame that we use. So that is the DF, okay? Did you have heart disease? Yes. Did you have heart disease? No. And if you have heart disease, did you smoke or you don't smoke? You can see here, those people that did not have heart disease and smoked, they are much. They smoke, yet they don't have heart disease. So this can also prove some statistic if you are trying to do some hypothesis test, even by mere visualization, that doesn't really shows that people that smokes has heart disease, because this can show from here you can see that many people smokes and yes, they don't have heart disease. So you can see that from the note. And the same thing, even the people that has heart disease, many people don't smoke and they say yes, they have heart disease. You can see there are even more than the number of people that smokes and has heart disease. You can see no and yes. So oh, blue is yes. Okay. Oh, yeah, blue is yes. Yeah, it's correct. So, and yes, okay, those people that smokes and say they have heart disease, and those people that says no, they don't smoke. So just try to understand what this represents, what this means, and how to interpret your chart. There are lots of this chart you can do. This is another one where we call the pie chart. Okay, as simple as ABC. So it's just to copy your code and just set appropriately. Just set all this stuff. When you set them, you can the size. You already know what the size represent. The label, the index, the auto CT. Like there is a way you can even bring this out, export. So if you click it, it's going to tell you so many things you can set. You can set on this. I'm not saying that yet. Okay, if you can see all this, if you check, you can really see all these things that are set. X explode, None. If I want to explode, I think explode, I can explode it and remove auto PCT, color, labels. Just play around all of them. You don't need everything. The most important thing is that you are able to get your data, you are able to communicate your data out. This is how far we want to go today. If you have any question, you can ask. Thank you for your time.
All right, and thank you for your time for what you've done so far. Yeah, I want to ask, I don't know if we can get a copy of the notes of these collab notes so that we can just.
Okay, data code. Okay. I think you can get it. I can just send it to WhatsApp group.
Okay, that will be fine.
So many Google Colabs we have used so far. I can just download everything and send them to the Google Colabs.
That would be helpful. That would be helpful.
To the WhatsApp group rather. Yeah,
Okay.
that is
Can
not.
I ask a question here?
Yeah,
I work with placement data for young people, and we have many variables such as costs, different costs for the placement care packages. We have different age groups for the clients. They may be under 16, requiring a different level of support, over 18. So can I use these charts to represent and the length of the period? Because they may have a placement for a few months, and that might change. So can I use some of these charts, but then I can only use two variables, X and Y.
Yeah, it depends on the columns you have. There are sometimes you can plot column, you can plot chart for each column.
Okay.
Understand? And there are sometimes you may reason that you should combine the columns.
Okay.
If you check our Google Colabs, there are some of them that we only let me share again that we plotted. Let me share the collab again. Oh, what's this? All right. Okay, yeah. Can you see my screen?
Yes.
Okay. For example, we want to plot for just only heart disease, just the column, just a single column, right? And we use this. It's only plotting the column heart disease for us. I hope you see this.
Yes.
And the question is just, did you have heart disease? Yes or no? The same thing we plotted for the race. Okay, this is just telling us all what we have in the race, the white, the black, and etc. Just only a single column. The same way you have those your age group in your data you are dealing with. You can plot for the age group, okay, such that all you only have to do, the column of the age group, you just put it down, and then it's going to calculate the size for you and those age group combinations you have. Of course, you have the same thing. We have the same thing here. Let's use we have age group here as well. Like here we have age group. Yes. Let me check. I cannot remember okay, let me just bring the data up here. The F. Let's assume that we have the F here. The F, so that we can see the age group. We have something we call age. This is a column that will look like the column you are talking about, right?
Yes.
The age group, and this is an age group. This age group, it will be better I use bar charts for it. If I want to use bar chart for the age group, I will just copy this one. I will just copy this chart up here. This bar chart I have up here. This one, I can just copy this one, or I just replace. Instead of putting race, I just copy the bar chart, the the age categories I have here, I just copy it and place it where I have race. Instead of race, I can just replace it with age group, like this. So once I replace it, that is all. The only thing I just have to change is of course, I was actually plotting age group and not race again. I've just changed. And the same thing here. I have the race against this, no more race. If I run, it's going to plot the chart for me of everything I have in the age group. This is it.
Right, okay.
This is the age group I have. This is it. They are standing alone. It's not as if I'm comparing age group with another thing. So
Yes.
if the other thing I can do now is if they are in a class, I can combine age group with a class and say, if you are in this particular class and this is your age group, I want to combine two of you. And in that case, this is the kind of chart we use for that. Okay. Here we are actually plotting the white against whether they have heart disease or not. Those people that said yes or no. Okay. So this is when you want to plot two things together, you use this chart. And the only difference is in this place, we specify the other column we want to use. I hope you're getting it now. Hello?
Yes,
Okay.
I understand.
For example, now, I want to check the age group. We are plotted for the age group. Let me change this to age group. The age group. And I actually want to see their race. I want to see the race they belong to. I think the race is capital, okay? If I run it, of course, I have to change this to age group now. Against race. It's no more against disease. Race. If I run this, it's going to be telling me the race and the age, okay? This is it. For this particular one, between 555 to 559, the one that is blue, let's check. The white, they are about 1,006 something. And the black, the black is this colored one. They are about, you can see, this is a group. This is another group. This is another group. You can see how I group them based on their race. I hope you get that now. So it depends on the one you think you want to combine. Do you understand? Your data dictates the nature of your charts. Your data dictates the nature of your charts. So, but basically, you will love to use every column to have their own chart. You may not want to combine them. So it will just be as simple as this. Those are the things you can do depending on your data. So that is all I can say. So, hello, everyone. Hello,
Yes, that's
everyone.
fine. Thank you.
Hello. Oh, yeah.
Yeah. So if you have any question, we can have before we call it a day.
Yeah. About the Okay. Sorry, not you. Yeah, for sorry.
Okay.
Thank you.
Okay. So if there is no any further question, so we can call it a day. I will send the Google Collapse. I will send it to the WhatsApp group.
All right. Thank you very much.
Yeah. Thanks for coming.